So now in this video we're going to make a current source with an NPN bipolar junction transistor, the 2N3904. The pin layout is emitter at the bottom, that is the arrow, base in the middle, and collector on top. The flat side is to the right. So in any case, the way that this works, we want about 10 milliamps of current. We're actually going to have a little more current because we got a little bit lower value resistor. I'm using 470 ohms. But in any case, we want to put 5 volts across an approximately 500 ohm resistor because that will give us 10 milliamps of current. So with an NPN bipolar junction transistor, this is basically an emitter follower to build up the voltage across that resistance right there. It's called that because with the zener diode, we're going to build up, this is a 5.6 volt zener diode. When current flows through it, it builds up about 5.6 volts. Any current above that, or any voltage above that, causes current to flow through the zener diode, more current to flow, so it holds the voltage steady. Passes current as needed to hold the voltage steady. So we're giving 5.6 approximately to the base of the NPN bipolar junction transistor, and that transmits, you lose about 0.6 volts. So it transmits 5 volts across the resistor. Now the current flowing through the load, we can just do the meter, or we can do an LED. Doesn't matter. As long as the load doesn't need too much voltage, LED only needs about 2 or 3 volts. And so we got a higher voltage than this 5 volts because the total voltage needs to add up. But whatever the load is, as long as it doesn't drop too much voltage, we will have a steady current somewhere around 10 milliamps. So now we'll get the meter ready to measure current. Need to make sure the red probe is in the right spot. Black is calm. It is right there. Everything but high current goes there. And then we set the meter to measure a current higher than we're going to measure. There's no numbers on this, just milliamps. It goes up to 600 milliamps, I believe, with this particular meter. And I have the power supply set to 10 volts. And current is limited to 20 milliamps. So if we accidentally short circuit something, we won't damage the meter with high current. So in any case, we just need to bridge the gap here with the probes, and we will get the current measurement right there. So you see it's about 10.6 instead of 10. That's because I'm using 470 ohm resistor instead of 510, so it'll be slightly higher. Plus there's probably some other factors raising it a little bit. But we have about 10 milliamps approximately right there. And there you can see it's the same current even going through the red LED. So we bridged the gap up there, and the LED was next to the transistor. Instead, we could put the LED, and blue LEDs drop more voltage than red LEDs. So normally you would expect less current, but there you can see right there, pretty much spot on the exact same amount of current. And current probably going to go up a little bit as the transistor heats up and whatnot. It will change a little bit, but for the most part it's holding pretty steady. Now when you measure with current, as soon as you're done measuring current, make sure you get it off of measuring current. I'll put it on voltage if it just has a power button or something. This meter has an off setting, so I'm going to turn it off. And these days I like to take 2-channel oscilloscope measurements. So usually I'm taking changing voltages. It will a little bit, but not for the most part. So we have the zener diode there. Again, remember it's got to be reverse bias. You should have seen that on the schematic. But cathode more positive, anode more negative, backwards from how normal diodes work. So in any case, clipped channel 1, yellow, to the zener diode, and channel 2 to the resistor. We're getting the voltage across the resistor right there. You can see it's about 0.6 volts less than the zener diode. Now we need current flowing. I have this jumper, and it was passing current. Now you can see with the current dropped through the resistor, we don't get a buildup of the voltage across that resistor. It throws it way off. When it comes to looking at the voltages, you need to have that current flowing through. So now we're going to put an LED in series, and it didn't matter if it was the blue one or the red one. We already saw it passes the same current, and the voltages now build up again because we have current flowing through. It helps that transistor build up the voltage at the base. And so there you can see that we have the same voltages again. And by the way, this is 1 volt per division. So I got 0 set for both channels. Down at the very bottom, 1, 2, 3, 4, 5. And we have the power supply set at 10. So voltage could go higher there. I'm not using a 5 volt power supply. We're not at the maximum. And in fact, it's a 5.6, so slightly above 5. But in any case, since it's the red LED, we can probably go down. Maybe backlight turns off after a little bit because I'm running on battery. Let's see how low in voltage we can go. Okay, yeah, 7 volts. We lost a little bit. Still, maybe acceptable for some application. But you can see 6 volts. We don't have enough to power the emitter resistor, transistor, and the load. But at 9 volts, at 9 volts we do. So we'll go back to 9 volts. Now we can go up, since we have a red LED, probably like 15 volts or so. Probably nothing will heat up. And you can see the voltage across the emitter resistor and the zener diode stayed the same. Current may have gone up a little bit because a little more went through the zener or something. Because that did change a little bit, but this isn't completely accurate. So that's not, the current we looked at before was just what was going through the load, not the total circuit current. So in any case, let's actually set this back to 5 volts. That's normally what I do when I'm not using it, so that I know that it's probably 5 volts and a maximum of 20 milliamps of current when I turn it back on. And let's power off the oscilloscope. Usually got to press it twice there. And it is off. Make sure that's off, not waste battery. So, in any case, I hope you enjoyed. Make sure you check out one of the other videos that I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.